What's up, guys? How have you been? I think everything is okay from your side. I'm really excited today again to present you this new tutorial suite of tutorial video, especially for structural and the bridge design. So today we coming with this new stuff, and we talk you how you can just make just simple modeling, and maybe by the far show how we can just design and apply some structural load for this state bridge. Just after this tutorial video you will be able to design this suspension, not suspension, excuse me, this state cable bridge. So we show you all different methods how you can just from simple to sophisticated bridge, and you will learn many things about. So as you can see, you will be able to design many kinds of a state bridge, any type, any structure and architecture design of this TD bridge. So this is aim of our tutorial video. Will show you, because the bridge model used in this tutorial is simple, because its purpose is to explain the analytic thinkings, maybe, and the 3D modeling. So you will see how you can make everything. So for our tutorial, we show the export, the workflow. I'm talking about the interoperability, between AutoCAD 3D and Autodesk structural bridge design. I'll show you all different handle manipulation from this. So after to talk about Autodesk structural bridge design, for this year we're coming with some simple and a special demonstration stuff for many kinds of structural software, especially for bridge design. So for Autodesk structural bridge design is one of parts software in the Autodesk AC collection, but it's limited just for simple bridge. And so when you want to make some sophisticated design and long bridge, you need to know more about, to know some software you need. For example, I'm talking about in the future about Midas. I'm talking about Midas Civil. What is the software? What the main benefit to use this software? The interoperability, the workflow between this Midas and a structural bridge design. What the difference between a SAP 2000 CSE bridge and sophisticated bridge and Autodesk structural bridge design. I will try to make those differentiation between all the software, the particularity of each software. Maybe you can see pushover, we can do this analysis in Autodesk structural bridge design. In the same way, you will see the workflow between Autodesk structural bridge design and the robot structural analysis. To not be long, I will just show you firstly how we can begin these modelizations. So the first of all, you need to add the recent project you need to save, because you need to create a cable, a new complex bridge. After, you need to define the standard, you need to define the design code, always working with a bridge standard. And after, I need to go to option, so I'll coming back for tension grid and memory, not for memory management, but for the preference, and go for graphic, and check this. After, you go to structural, and then you need to define what the type of structural we want to design. Firstly, you go to bridge type, foot bridge, and go here. There is a line beam and the refine model. So I'm going for refine model. This option will help me and will allow me to import my 3D AutoCAD model. When you go to AutoCAD, coming back for AutoCAD, this is our 3D model. There is just some vectorial line and arc, line and polyline, just auto as I change TFX, I click save, replace. Okay, I'm coming back here, and I click here to export my model, so I can see state bridge, new bridge, watch time, new folder here. I'm coming back here quickly. What can I do? Okay, design. I have this. What happened? There is some mistake. Of course, I delete this. I resave again, and I go back here. Yeah. And click here. Okay, that's okay. Export. We have this. If there is something you want to not used from our layer, you can just uncheck here. I select all and select. Okay, meter, the unity, and so we have our 3D model. So after having our 3D model, this is our 3D model of our bridge. There is some other things about Unity. You will delete this after. So after to do this, what's coming next? The next step is just to go to material. You may to select. You must to create and add the type of material you will use for designing your bridge. We'll use pre-stress maybe, and after steel reinforcements, yeah, and we need to use this structural style. Okay, that's okay. The next step is just to design your section or your beam. So we'll design our section. The first of all, to design our section, I will just show just one of example. I will coming back after. The first is to design is the cable suspension. I'm going. I go at this option and I select a steel. It will be which kinds of beam. It will be a circular hot finish. Okay. The serial with range, which we will use a 139.7, and you cable suspension. Okay. After we'll define all those section. So after to define all materials we'll use to assign for each members for our structure, we will checking again. As you can see here, we have a for the first section is for the cable suspended. We'll use it for our suspended cable and suspended cable, and the section 2 is the cable stay supported for this true cable which supported our pylon to do not slanted from different loads, winds, and so. And after we have the second tree section is the generic shape. Our generic shape is a annulus. We use it for the pylon, our pylon. And the section 4 is a rectangle. We use it for this traverse. Let me rotate for this traverse. And after we have the section 5. Our section 5 is for the deck beam long. We use it for our longitudinal beams, as we can see here. Not for this. This for 3 beams. So we have our section 6. Our section 6 is the basic shoulder, these two beams, and the section 5, 7, we use it for the traverse. Our traverse Adam traverse, we use it for this, and the section 8 is using for horizontal bracing. We can go in here and see our layer horizontal bracing, and aft for our members. Section 9 is for the deck. Is a pyramidal shape, but it's a sickle. We use it for our deck, not for our deck. We use it for our pieces, our pieces, for our substructure foundations. After we have it, we can begin to make some assignment. But before to begin this assignment, we can just focus some adjustments. Our adjustments, we use it to add we use it to add some finite element surface, which allowed us to assign for surface element members. So we can just go for the deck, not for the pile cap. This is our pile, this is our piles cap. Yeah, this is our piles cap. So we can go to our piles cap, go to structure definitions. I'm coming back here. We have it, our structure, and we go for our pile cap. No, yeah, this is our pile cap. No, this is our save, our pile cap. So we can just go here and pile cap. We can try to make some definition here and here. Let us check. This is our pile cap, and we go here, save first. It's just a surface. Okay, we change, we add. Okay, we go to our handrails. We can just go there, handrails, yeah. Okay, members. Firstly, for our handrails, we may first define our vertical surface, the limit of our rods. We're going here, and so okay. After we will delete all beams. No beam here, is just, oh sorry, cancel. We begin surface, this and this. Let me zoom a little bit. Okay, after I must delete all these beams. It's not important. We just stay with a finite element. Okay, after all, we're going for our deck. For our deck. No, for our deck beam long. Okay, for our deck beam long, we have it. yeah, deck beam long, and then we can just go here. We have it. May I just add some additional for our carriage way, and we have to go to basic shoulder, and we click here, and we define some FE element. We do this because it allows us to define, excuse me, let me define. Okay, so as you can see, we almost finish our design. May I just, as you can see here, there is no, until now, no materials assigned for each type of member. So we'll begin by our suspended cable. We add here is our first section. We go to the filter, we filter our cable suspended, we make some shell selection, and we add okay. Our second element will be the cable supported, so we add the section 2, we select all these 2 cable, and the section 3 will be our pylon. We click here. Sorry, there is some duplicated element here. Let me check when a pylon is for caps lock. So here we had our first element. We click OK. Section 4, it will be for this pylon traverse. Okay, section 5, it will be for our deck beam long. We need to add our section 5 for these 2 good beam. Section 8 will be for our basic shorts. We add section 6, excuse me, okay, already did. And the section 7 will be for our traverse, so we add our 7 section. We have a filter, we select everything, we click OK, and after we need to have horizontal bracing. Our horizontal bracing is this. So section 7, 8, we selection everything here, add OK. Pierce, we selection section 9, we have this. Okay, and after we go to add some infinite elements, assignment materials. We're going to our deck beam long, and we add some finite elements. We give the thickness. Our thickness will be 400 millimeter. We make some description. We make assignment. Okay, our second finite element we use for the basic shoulder. Our basic shoulder we give the 300 millimeter. We make a basic shoulder. It's because it's a finite element. We go to the filter. We selected basic shoulder. We click for these 2 elements, our surface, And the third finite element stiffness structure properties infinite element assignment, we'll put just for pile cap. Our pile cap is there. Yeah, we have our pile caps, go better. Yeah, we make this, we assign, we put for 800 pile caps. Okay, and for our handrails, yeah, for our handrails, we just add another finite element. We put 200, and we a handrail. Okay, et puis after we select all elements. It's done. So we finish our modeling, which was the purpose of tutorial, just to show how you can model this. And after, you can just add and go to 3D. 3D give you a great view and overview of your 3D model. This is our structure. We have all different elements for handrails, for traverse, for horizontal bracings, for cable suspended, for pylons, for our supported pylons, for our pile caps, and for our, because it's a deep foundation, for our piers. So this was just the proposal for this tutorial. So after, if you want, you can go far. If you want to make some advance or some studies, so you can go there, just click here, you add some not it, you can just select, you go to all join, you select just for 3. So yeah, to do this, you may have some knowledge about structural analysis, to know who, when, why, and which moment I can add as supported, fixed it, as in uniform or variable or free or springs. It depends of a degree of freedom. This is some knowledge you must know before as a structural engineer. For structural design, the degree of freedom for each element, for a bridge, for structure, substructure which supported our pylon bridge, you must have some this knowledge before to make some parameters and some modifications. So there we can go to the pile caps, not pile caps, for piers, yeah. So you can select all these elements, define some element like design line. Design line will help you to activate it. For example, our design line, I'm clicking here from here, and I design my line. This line will allow me to add some carriageway. When I'm going here, I go back here, you can see carriageway is added. Carriageway will allow me to add some, define our line of road, 2, 3 or type of road. When I define this, you see line road, single and dual. So you can then make some adjustment here about the first footway, the second footway, the primary carriageway. You can define also the offset, and so you may have some knowledge about the load line for assessment. You can adjust, you can just as B2. This is a long the recommendation for the British standards for bridge design. So you must have this manual to know what you can do to do not make some mistake. So here we have just this, and after, when you go to load apply, you can see you have the possibility to add other different loads, maybe for idle, you can just go here to here. Could then have these positions here. For this here, you can just add your rods and add some applying loads. You can go to here, vehicles. You can define the vehicle as of your rods. You can see here and do you add, and so fatigue. This is some all kinds of loads. You can add some a live mobile and did load you can apply for your road. When you want to add the convoy load, you need to create this. The same for assessment live either. So there is many things to do. As you can see here, I can add everything. I can go far, but because I can define for my slab, I can define my prestresses. A line. I can define different line. For example, this line, I go from this line to this line. You see, this is my definition, and so you can make you can put some high here. You can maybe fix it and make it variable. You can see the profile of your cable stretch tendon. You have here the area of tendon, the number of tendon, the depth diameter of your tendon, the material properties, the anchorage, and you have the tendon tip, because this is just the notice. For structural bridge design, you can just use only internal permanent for the tendon tip, not internal temporary, not only just this. When we click here, you can define another profile, and so you can have many 1, 2, 3 or many of type of profile you may need. And after, you can just add, click here, and you run analysis to have some first structural analysis, a graphic load behavior, to have some moment, curvature moment, bending moment, stress, and our internal force, strength. And so you can add virtual member, you can add some defense, some post tension tendon, and so you can add the special vehicles. There is many things you must know about this, but our tutorial video just was focused especially to show you how we can just design, only just for design modeling. Maybe for the futures videos, we'll try to talk you about how you can just add some calculation, how to make a structural design. That was especially only just for design. Thank you so much. If you like the video, don't hesitate to like, comment, and share with our community. Thank you so much, guys. See you later for the next video about structural or bridge design or civil engineering, a design from simple to complex. Thank you so much, and see you later. Bye bye.